It's Mrs. John with lesson 2 for year 12 physics, and this lesson is on balanced forces. So just going back a little bit over lesson 1, when all the forces are acting on an object are balanced, then the object may either be stationary or it would be moving at constant speed in a straight line. Now, when the forces acting on an object are balanced, the object is said to be in equilibrium. Now just look at when there are two forces that are balanced or they are in equilibrium, we can say that they are balanced if they are the same size but they act in opposite directions. So you've got 10 newtons acting this way, and to balance that you need 10 newtons the other way, or it could be up and down. You can also have three forces that are in equilibrium or balanced if the vertical components, if they're added vectorially, they form a closed triangle. So these are three forces, they're balanced. And how do you add them vectorially? You keep one of them the same, and this blue triangle, I just translated it over here, and this other one, I just translated it there, and you get a closed triangle. And also, when forces are balanced, the sum of the vertical components is 0 and the sum of the horizontal components is 0. So I've just given some values. If there's 8 newtons acting this way, then the vertical component of that, let's say, is 3 newtons, and the vertical component of that is 5 newtons. So the 3 and the 5 up will balance out the 8 that's down. And then horizontally, you've got 6 newtons this way and 6 newtons the other way. So that's how I say they are 0. And here's some examples of how I use them, the components of forces over here, and how to show that they are balanced. So you can just take a look at this question here. So a box slides down a slope at constant velocity. The slope makes an angle of 30 degrees with the horizontal. So what I did was I got the size, and the weight of the box was 10 kilograms. So I got the gravity force acting on it, so 10 times 9.8. And then I had to find out the size of the friction force. So that's my 98 newtons, and this is my 30 degrees. So this is my hypotenuse. Friction is what is opposite. So I could use sine and get the friction force, which is 49 newtons. Now this little bit is about comparing the size of the reaction force to gravity force. Now if something is resting on a horizontal surface, then you have the size of the gravity force down equals the size of the reaction force up. But if something is at an angle, then the support or the reaction force decreases. And as you keep increasing this angle, the size of the reaction force will get less and less. When this is like vertical, then there's no reaction force at all, it's only gravity. Okay, and that's my lesson 3.